Alright, time for another draftphysics.com. Debatephysicsalso.com. Without the also. Um, but it's just nothing. There's no debate to be found. So anyway, the YouTube update video. Eesh. Anyway, so I did a few videos. Some of them not so bad. The science is dead one, the last one. I'll probably kind of redo some of the statements here just because it's, this is just, I wouldn't have expected it, simply. I mean, you have some pretty good arguments here about what the truth is. Lots to debate, lots to, point out, this absence of evidence. And here we are on this search for the truth, and nobody thinks you need evidence to have this argument about the truth. And that's a pretty glaring statement of just how this is just a battle of flat earthers, and this is a battle of truthers against truthers. It's not about finding the truth or establishing the truth or proving a truth. It's really bad. Anyway, so this other one on energy was kind of a good one. Energy and matter, because I just attempt to explain, how, the circle of energy, which is the circle of everything, just starting with a very simple mechanism, and the energy just flows from the little tiny universe into the big universe, so to speak. So it's a little bit of that kind of thing. Now the rest are just arguments about the dispar and the brozo, and they're silly, poorly done, crappily presented, shittily argued experiments. Where physics, they don't care about the details. How something actually works. And so that sort of relates to, finding it. A comment by one of the assholes. This is mindless marbles. You can live with these kind of statements for the rest of your life. It's okay with me. In Gary's latest video, he comes out with immense hypocrisy. He claimed over and over that clay isn't a reliable measure of energy. Yes, I've claimed it over and over that clay has certain properties, and it'd be so much better to use springs or some other mechanism, some storage device, where you can tell exactly how much energy you've collected, because you can give it back again and see how much you collected. And if you create a mechanism like a spring that has minimal losses, every system you create, if you use air pressure, you use this, you use that, all of them have moving parts have friction, so nothing's perfect, but it's like a lever. Lever's pretty good, not bad, at storing and giving back energy, and you can just watch it like a pendulum. You can watch it go back and forth 100 times, and you can say, shit, that's pretty good, it's pretty efficient in terms of keeping the energy in the system. I've pointed out that I wouldn't use clay. It wouldn't occur to me to say, hey, what's a great way to measure energy? Well, let's see how much it deforms clay. Well, and I've pointed out why, and, all of that's ignored, so they can say something stupid like this. Now, all I did would point out is the Mythbusters experiment is, you got to admit, a better use of clay, I would argue. It's simpler. You'd have to argue that they spent some money doing the experiment. It's certainly videoed better. So it's that's putting the ball in your court. And instead of dealing with the ball that's in your court, instead of explaining why you thought the 1700 clay experiments were the man, they proved it. Well, how come your proof isn't holding up, though? There's another experiment, a competing experiment with the same material that's demonstrating completely opposite results. And so you just, instead of dealing with that fact that the thing that you, as a hypocrite, said was a good way to measure energy, all of a sudden now isn't a good way to measure energy? I mean, what's your explanation? And again, I would argue that if you really think about the two different kinds of experiments, you can understand why one of them is probably going to give you more accurate results than the other. So I'll demonstrate that for the fun of it. But let's just finish this stupid comment. His claim over and over that clay isn't a reliable measure of energy. So my claim was this isn't the best way. That was my claim. Nobody established that clay is some sort of perfect mechanism, that it does the same thing when you first hit it as it does when you go through it, or any of that. There's absolutely no evidence that this is the way to measure energy, how far something goes in a piece of clay, or how much displacement there is, to use Brozo's moronic analysis. Anyway, everybody here can attest to this. Yes. Okay, and what they can also attest to is that when I found the Mythbusters video, okay, it occurred to me to say, there's a pretty good piece of competing evidence. I didn't sit there and say, oh, game over, you lose, I win, blah, blah, blah. I didn't do any of that. All right. I said, this is a pretty good piece of evidence for my team, right? All right. What's your counter argument to this piece of evidence? How do you destroy this piece of evidence? Okay. It's been viewed by millions of people. They can't find these huge flaws in it that you're finding. So why don't you explain why it's so frickin' inaccurate? Wow, it's so illogical. What they did is so illogical. Can't hope to get the right answer because it got exactly the wrong answer. So let's just understand it got exactly the wrong answer. Okay. However, in his August 31st video, he comes out and says that the Mythbusters video where they squish the clay proves him right. I'm sure I may have used different language, but I'm sure in every one of those things I made the contextual statement where I said it's a pretty strong piece of evidence. Yes, I believe it's a pretty good piece of evidence. Compared to what you've shown us, which is crap, it's a pretty good piece of evidence. Now, in the context that, Brozo is the big liar here, because, he did clay experiments a year ago, and he couldn't duplicate the, Madame Chartelet results, because he wasn't using round spheres. Okay, so I pointed out how, you can figure out why the shape of the object makes a difference. And it's kind of as simple as pointing out why, arrows with points on them work better than arrows with no point on them. You can make logical arguments explaining why there's a difference between, what shape the object is that you're penetrating the clay with. And again, all of that is, you get rid of all of those. They're really two different uses of clay, right? It's really not the same experiment. All right, anyway, Manny is just such a greasy liar. So obviously there was nothing lying in the video. There's nothing you could call a lie. I've never lied about what I'm showing in the video, the experiments or any of that. And all I'm saying to you is that, I think, you were so proud of your proof and you shove it down everybody else's throat. Okay, Madame Chartelet's clay experiments, for 200 years, that was the great proof. Well, I'm just saying, now the ball's in the other court. Now you have to explain. And you don't want that obligation. You don't want to use any logic and apply it in any kind of fair manner. All right, so after the Mythbuster video, he thinks looking at clay is enough to bolster his claims. Well, I think it bolsters, so that's a key word, right? Yeah, I think it does bolster my claims. And I pointed out that neither the crushing of the cars didn't show kinetic energy, nor did the clay show kinetic energy. Both of them dramatically, decisively, said momentum wins. I mean, pretty dramatically, pretty securely. It wasn't like even doubtable what the results were. All right, and so it's your obligation to explain with something a little better than crushing a tin can and say, why exactly does it come out that way? Why does 4 times the energy look like twice the amount of energy? I could even argue in this very video you're commenting on, so I'll show it. I'll post this moronic comment here first. I believe it's the right place. Let's just make sure. This is what I need. All right, as the cylindrical clay sample is squished, its length contracts, and as its diameter grows, I guess that's what it says. I don't know what correct question mark means. Its area increases, correct? so what? It's going into a minimal. The air pressure on the outside doesn't change, so it doesn't add up to more pressure. You can't say it's in a trapped space and therefore it's creating more pressure. It's released at the same rate. Pressure is force divided by area. Well, so says U, which is more crap. So the pressure must decrease. So the area in contact with the cylinder is the same. So that area doesn't change. And the area being excreted has absolutely nothing to do with how much force it takes to squeeze the stuff out of the tube, so to speak. I mean, you could compare this to squeezing toothpaste out of a tube, okay? It doesn't get harder to squeeze the toothpaste. Now, what does get harder is to find the toothpaste and push it out the end. It gets less and less in the tube, but if you pushed it from the bottom all the way up, it doesn't get harder to get the toothpaste out of the nozzle at any point. All right, it is a nonlinear resistance to force. So again, just make shit up. Say it as if it's the truth. There's nothing non-linear, okay, about the rate at which you're just converting the pressure this way into clay moving that way. And that's all the cylinder is doing through the whole process. And as long as there's clay between the two surfaces, that's all it's doing. It's just pushing clay that way. And the air pressure is the same for every bit of clay it's pushing, so it makes absolutely no difference. So it's, again, a bullshit argument. All right. So this is all they got. This is their great counter argument. Is this nothing? Bullshit. Yeah, it's disgusting. All right, so here's I'm going to simplify the experiment for the sake of, you have clay and you're just going to smash it against the surface. So yes, technically they use 2 weights and all this other bullshit, which I found totally unnecessary. But anyway, so you're going 4 times the height, all right, to get twice the velocity. I'll keep emphasizing that. It's only twice the velocity. It's only twice the amount of time in the gravity. All right, and they'll just keep ignoring that. And then you go 1/4 the height here. All right, and do the same thing. So this is the 1 unit of distance. This is the 4 units of distance. And the whole point is that this is twice the velocity. All right, so you really just want to compare a 50-mile-an-hour crash, which this would be, and this would be the 100. So, lots of ways to point out, like I said, I could make this into a 1 mass, and then we could do the 5-ton train versus the 10-ton train. All right, and what do you get as results is that the 100, that's supposed to be 4 times, okay, only crushes the clay twice as much. So the 50 does this to the clay, and the 100 does, this to the clay. It's only twice the compression, not 4 times the compression. So you don't get the 4 times you're supposed to get, you only get twice the compression. Pretty clear. So when they crash the actual cars into the wall, the same thing happens, okay? 50-mile-an-hour crash does this to a car, and then the 100-mile-an-hour crash does this to the car, half of that, just 1/2 of the compression, not 4 times the compression, which is supposed to be. All right, and again, I pointed out this is because gravity is a time-dependent force. It's how long you're free-falling in gravity will create your velocity and your energy. And your velocity and your energy increases at a rate, 1, 3, 5, 7. This is the rule, and this 1, 3 is the important part. Okay, that's the part showing you how it works. Okay, that the second part of your voyage, you're starting to move really fast compared to the first part. You only go a little bit of distance in the first one, and then you do this huge distance in the second portion of time of your fall. And and that's the optimum way. So if you want to you could go up the hard way. You can find hard ways to lift something. Or I can lift something very slowly, and I can use a lot of energy to lift it. Or I can lift it at the optimum velocity, which will get me to the top, okay, using the least amount of energy, because I'll use just enough to overcome the opposing gravitational force. And so, if you shoot something at the same velocity it would land at, okay, that will be the most efficient way for you to get X matter to X location, because you perfectly match where the location you want to get to. Use just enough energy to get to where you want to go as quickly as you can without overshooting and all of the other things you could possibly do that won't be more efficient. It's like braking and stuff. There's a perfect velocity for you to go, like say if you were only traveling 500 yards in a car, there's a perfect velocity for you to go where you don't have to, you don't have to brake, and you don't have to do this and you don't have to do that, right? So there's a perfect amount of, perfect efficiency. All right, so anyway, so this is the argument. So yes, this is a pretty good piece of evidence that there's no kinetic energy, that it's a fake, phony theory. It doesn't show up in this experiment. Now, I've pleaded with you to show me the experiment where it does show up, okay, where there's good evidence of this, where there's an experiment of this quality, okay, that you can show me, all right, where, yeah, they do find 4 times as much compression, and they do get this kinetic energy thing happens. Show me, where you prove any of this. And certainly in space, you're not going to be able to prove any of it, because, they know it's mass and velocity. There is no 1/2 mv squared in space. I made all these arguments over and over again, and you just don't care, because you're a fanatic, you're a religious kook, okay? You don't care about facts and evidence. You're just going to argue your Allah is God bullshit. Sing your little songs and tell us that's what the truth is. And you just don't care about this idea of, well, it'd be nice to have facts to defend your story with. And you just don't care. I guess I could be better to have that over there. All right. Yeah, so where else do we go? Yeah, so we'll do the clay stuff and just show a couple. I already provided these examples. Again, and to say there was some hypocrisy, everybody's, you have to analyze everything. So I'm just saying that you can understand that there's reasons why things happen. In every one of these experiments, I pointed out how, well, when they're banging this metal against this metal, because they use another piece of metal here. So you have metal, and then you have the clay in between. That, this hammer coming down could be a problem because it could bounce. But then I pointed out how, no, because energy goes to wherever the weakest point is. The fact is that hammers don't bounce. So if I take an anvil and I hit a little ping hammer against it, the ping hammer will bounce back. But if I take a real sledgehammer and smash the anvil, it won't bounce back. Not nearly as much anyway. Because it'll actually start compressing the metal. It'll have enough energy to use more of the energy in flattening, in changing the shape of the metal. It'll start changing the shape of the metal, using energy. Therefore, energy is going in, and energy is going this way and this way. It's being used. The energy does work. And so if the energy does work, it can't obviously reflect nearly as much energy. But the little ping hammer can't move the steel. So the little ping hammer has to bounce back because it can't use any more of the energy. All right. But there's reasons for everything. And just, And so you're sitting here pretending you're defending science. Science is doing what I'm doing, okay? Is explaining and finding the reasons why things happen, and finding the place where, oh yeah, we lost 3% of the energy here. That's what science is supposed to be doing, and you find that obnoxious. You find that hypocrisy and cheating and lying. Yeah, no, that's not what it is. It's science, asshole. But this is all there is, in this conversation. That's the part that's just kind of grotesque. This is I've been doing this a long time now. on the fact that it hasn't provoked any interest in any science-minded people at all. I mean, none of them are showing up to say, hey, that's a good point. Hey, that's a good point. We should have thought about that. We should have an answer for that. We should be able to show you evidence for that. And instead, they just run away. I mean, you point out how they haven't been able to repeat this Eddington thing. You point out something like, Jupiter is sitting right out there. And, as Einstein points out, yeah, well, the experiment's 100 times harder to do against the surface of Jupiter. But you have this huge advantage, because you don't have as much gravity. But you have the huge advantage if you don't have any corona. You don't have any of these particles flying off of Jupiter. So you have a huge advantage in that respect. And the fact is, from space you have a 400 times better resolution. So yes, you lose 100, but you still have 300 times better resolution. So it's still a far easier experiment to do Jupiter from space than it was for Eddington to do the sun from the surface of the Earth. 300 times better, easier experiment. What Eddington was doing from the surface of the Earth was, just almost insanely silly compared to how easy it is from space. I mean, the gigantic difference. And you don't account for any of these facts. You just run from them. Pretend they don't exist. So in all this time, again, there's no excuses. Oh, we can't take our telescope and put it too close to this, but you can't do that. Yeah, you can. It's just such a pile of crap. All this excuse making. Alright, anyway. I shall erase. Alright, so some of this might be redundant to some people, but that's life, sorry. Anyway, so we have two clay experiments. Alright, we have one where you just smush the clay, okay, between two objects, and all you're really doing is saying this is a constant rate, okay, that you're going to be pushing clay out this way. So you're converting energy coming this way, and technically, this way, even though this isn't the moving object, but it's the same idea. The pressure will get to it. The pressure will have to be converted into motion this way. So you're just squishing the clay. All right. And the fact is there is no increase in pressure out here, so it is linear in the sense that it's the same amount of pressure. As long as there's clay in here, you're just doing this part. That's all you're doing. Okay, that's all that's really happening. So it's not going to get harder and harder. There's no reason to believe it gets harder and harder. And there is good reason to believe it gets a little easier, actually, to compress the clay. Because we know that anybody who's worked with clay, I mean, I've done some sculpting, it gets easier to manipulate it the more you manipulate. So the more you move it, the easier it gets to move. Okay, it softens. With temperature too. Alright, so anyway, but that's one experiment. Now the other one is this idea that you take a lump of clay and then you drop crap into it to dent it. Now the trick here, as I pointed out, is that these round surfaces are significant, okay, because you have to kind of understand what's happening on a round surface is that this is the flat part of the circle, right? The circle's this way. And this part is this way, okay? So it's almost like you could say it's an arrow without being obvious, right? That there, in a sense, there's a triangle inside of this this circle. I should draw it the other way, right? Then I get into pentagons or something. This is the flat part, and then it gets, So when you're dropping things in clay, all right, what's happening is that when you first drop them, you're pushing this way, and as they go deeper and deeper, they start just going, this way. There is no pushing sideways. There's just pushing, the clay is just being slid, okay, past the surface. So it's a different, the point is it's a different, the impact is going to create a different effect. So when I first hit it, right, if I hit it with just a little lump, you can also understand that it pushes this clay up. So just like a meteor hitting the moon, it creates those little mountains, right? It pushes up, okay, up. But it doesn't do that once it's going through. It's not doing that anymore. It's not making any more of this up stuff. Okay, and all it's doing is creating a deficit, a hole. That's the width of the object you dropped. And so as I pointed out, if you're going to fill something in here, you're going to fill this with fluid to say, well, how much of a dent did it make? Well, it's not really a fair experiment because the initial, the thing that barely dents, is displacing technically more clay than the thing that goes way through and does this. The thing doing this, the amount of distance it travels will be proportional to the amount of displacement because it's not making any extra displacement. Where when it's making the initial little lump or bent or dent, okay, the fact is it is displacing more, okay, than its distance. So its distance down won't reflect the amount of volume because of this shape change, because you're going from this way, okay, having to move the clay exactly that way, to surfaces that don't have to do that anymore. And that's a big difference. So if you really want to do the experiment fair, what you have to do is make sure that both objects, your fast and your slow object, that both objects have enough energy to dent the clay past half their circumference. So as long as they're both in the clay past halfway, then you have a fairer fight. It's still not going to be fair because you still have a higher percentage of this one's voyage is going to be doing the lump making rather than the penetrating. So there's two different things you're doing, pushing clay this way and pushing clay this way. And the deeper you go, the higher percentage of your displacement will be this, and the smaller percentage will be that. And the less far you go, the more percentage will be this, lump making, versus penetration. So that's an argument against your theory. Okay, the experiment you think is the winner. Okay, I'm pointing out how it has flaws. Now your obligation is to go over this experiment, explain how it has flaws, how there's a reason why the 4 times didn't show up, that somehow this clay actually did get harder to compress. Like there is really some rational theory why it was harder and harder for the clay to get pushed out this way, okay, when it got less and less clay in between. That somehow the clay, the toothpaste, whatever, can't go out the nozzle anymore. So if I had a pressurized vessel, you know, and I put clay, okay, and then I have a cylinder up here, and I'm going to push the cylinder, okay, and squish the clay out through a nozzle, you can understand that all I have to do is put whatever 9 pounds of pressure here, and it's going to be 9 pounds, 9 pounds, 9 pounds. The clay is going to come out at a constant rate, and it's not going to change any. The rate at which the clay comes out of the nozzle isn't going to change as I change the amount of clay in here. It's going to push out at the same rate. And the same thing is happening here. So you don't have an argument. You know, you're not doing science in any way. You're not providing some reasoning that says this experiment sucks and this experiment is the valid one. So we have this experiment that has what I call obvious deflects, defects. And so this one shows your 4x thing. Now we don't know if it really shows that, frankly. Okay, we don't really have too much verification of the 1700 experiments. And the Brozo ones certainly aren't perfect to 4x. But anyway, you got like 3x. It gets lots of things, okay, but they're not exactly 4x. Now this was pretty much exactly on the nose, okay. Newton's physics works. Momentum is the mechanism. Momentum is energy, and it's showing you the energy. Now, I pointed out in the video, again, I would prefer just to put a spring in here, okay, and compress it, because frankly, I know that the difference between a 50-mile-an-hour crash into a wall and a 100-mile-an-hour crash, the difference between those two things is weight. All you're doing is changing the weight of an object. When you move an object, you make it weigh something. It weighs nothing this way or this way if I'm holding it still. As soon as I give it velocity, it starts to weigh something. And the more velocity I give it, the more it weighs. And that's the simple argument. And it's just different than your weight in gravity, because there isn't a constant force pushing you into the scale. So without the constant force pushing you into the scale, yes, your weight, the compression of the spring will absorb your weight. And unless you lock the spring or do something else, that will uncompress and your energy will disappear from the spring. But the spring will show it. The spring will expand or contract quite literally based on weight. 100 pounds, twice this stretch is 50 pounds. And that's all velocity is creating for any mass. I give any mass a velocity, I give it a weight, I give it an ability to expand or contract a spring. I mean, these are such, to have to even argue this with you people, is startling, okay, because that is such established physics. And you're pretending that somehow you have a piece of evidence somewhere that springs don't do that. That it takes 4 times the energy to compress a spring twice as much. Some of you morons say things like that, and you have nothing. You have no experiment to show me that it's ever true. Ever, 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 ever. All right, now I can just go back to the lever arguments. It's just, what's the point? You haven't countered any of them. You haven't pointed out how levers are not just conversion devices. That's all they do is convert one momentum into another momentum. And by doing so, if you change the mass portion, obviously, you have to change the velocities to match the momentums. And when you change the velocities, you exponentially increase the velocities, the energies, by your silly theory, because you're squaring the velocity. You're saying somehow velocity is more important than mass. So when I'm moving something, the mass is almost meaningless, and the only thing that means something is the velocity. When no, of course the mass matters. 50 miles an hour and 100 pounds, 50 miles an hour and 50 pounds. 10-ton train going 5 miles an hour, 5-ton train going 10 miles an hour. Same thing. You're saying they're not the same thing. You have zero evidence, though, to demonstrate that they're not. You can't show me one frickin' experiment demonstrating how the lighter object going faster with the same momentum has more energy. That's not I'm not asking too much from you. And you can't satisfy that simple demand. Produce an experiment. Produce some evidence. And you really just don't have any. You have 2 characters who are sitting there and can produce any result you want. Just pick a number and they can do the experiment badly enough to make that number happen. And that's all you have. And you're calling me a hypocrite? You're calling me names? You're disgusting. You're such a horrible, awful, terrible human being. Again, you can't produce anything. You won't explain how levers work. You won't explain how clay works. You won't explain how anything works. You won't show anything. You won't draw anything. You won't explain where the evidence is and why it's inaccessible. You won't explain why they haven't redone the Eddington experiment. You won't explain any of it. You won't deal with a single one of the arguments that have been made in these hundreds and hundreds of videos on this subject. You just do this. You just do this shit talking. You just do this insulting. And that's all you've got. And it's just so pitiful. Ugh, you're just such awful human beings. And it's just sad that that's all that's in the conversation. That's apparently all there is on Earth are awful human beings. I mean, what do we have? We have 4 people that might have shown up here, and been reasonable. Toady, a few others. Some of them you would call defenders of mine, so I won't even name those. But, can any of you be fair cops? No. Just really sad and pitiful. All right, so I'll pause there and decide whether there's any point in saying anything else. I guess I'll just throw in some extra little argument bits. So they keep, I keep doing some research on Einstein, this and that, and they keep calling it Newtonian mechanics, Newtonian mechanics, this mv squared thing. And it's just so funny that it isn't Newton's physics in any way. Okay, it really isn't. I mean, Newton was opposed to it when he was alive, and it's all, picking on it. It's just putting words in a dead man's mouth. I mean, you can't do anything about it. You're just lying about his physics. I mean, his physics was the equal and opposite thing, okay? You know, that was his physics. That's one of that's his third law. And the lever proves the third law wrong, right? The gun proves the third law wrong. So, you know, we've had this thing for a long time, guns, right? Okay, I mean, okay, you got 2,000 joules here. No, 2,000, we can technically make it 2. And you got 2 over here, okay? So where's the equal and opposite reaction? So why are you saying there's a third law when clearly you don't believe there's a third law? You don't believe in it. All I have to do is change the mass, have a constant force, a constant explosion takes place here. Somehow the explosion only creates 2 joules of energy this direction, and it creates 2,000 joules of energy this way. And joules are watts, okay? So it's 2,000 watts of heat this way, only 2 watts of heat this way. This is what you believe. This is what you're arguing and insulting me because I don't think that's rational. I don't think it's rational to say there's a third law, okay? And say Newton was right about that law stuff, 1, 2, and 3, but somehow there, you know, this is what we also believe. So there's a third law, but this is true. You can't have it both ways. All right, and then, you know, so I make this simple argument that you have this simple device, the lever, been around forever. All it does is convert MV into MV. So you can have, you know, you can have a big M and a little V, and then you can have a big V, okay, and a little M. And that's all it does. It just converts those two numbers, and it can't make free energy. You can't put a big M and a little V over here, okay, and have a 100 joules, and then over here say you have 400, you know, because you made the V bigger and the M smaller. You can't do that. That's violating the third law again. It's just nonsense. Can't happen, doesn't happen. Then I point out that I can put the 10-ton train, okay, going 5 miles an hour here, the 2 mass, okay, with 1 velocity, okay, and I can put the 1 mass, okay, with 2 velocity over here, okay, and the fact is, all right, they'll oscillate perfectly. I can put any amount of energy in, cause them to, you know, cause a gravitational imbalance. That is, I can push this one up into gravity, and this one, you know, will, this up will have to be pushed back down by gravity, and it'll just keep oscillating up and down. This will oscillate at the 1 velocity. You know, this one's got the 1, and this one will oscillate at the 2 velocity, twice the distance. All right. Could have done that better. Anyway, and there's no reasoning, there's no logic other than, yeah, well, that's what's happening. This energy has to create the energy to move this up. There can't be twice as much energy on this side than there is on this side, or this side than there is on this side. There can't be more energy. It's just converting the momentum, and that's all it can do. It can't make energy. So, you know, again, by their theory, I can have the gun here, okay, right? I put the gun here, okay, the recoil of the gun is the energy I'm using, and then I can move the bullet further and further and further out. And as I move the bullet further and further and further out, I keep making more guns worth of energy, okay, another gun worth, until I get to 1,000 times more guns. I can move 1,000 guns, okay, with their recoil velocity, with the energy of 1 bullet. So 1 little bullet, you know, going 1,000 times faster with 1,000 fewer atoms, somehow could create the recoil of 1,000 guns. That doesn't make any sense. It's insanely illogical. Obviously, it's just the recoil. This recoil, 1 recoil equals 1 bullet. It's all. It's the same energy. It's just 1,000, okay, times faster, and this is 1,000 times bigger. I mean, you know, how can you not get it, that that's the same thing? I mean, it's such a basic argument. Don't you think you should have one piece of valid evidence to point me to show me how I'm wrong? You don't have a single evidence, not a single good experiment. You can show me this whatever. You can show me the 5-ton train going 10 miles an hour doing twice as much work as the 10-ton train going 5 miles an hour. Why can't you show me one single solitary piece of good evidence that that's true? And yet you'll sit there and insult me. Amazing. Just amazing. I'm amazed. Because, like I said, I never liked people much. Never had too much respect for the human race. The bulk of humanity I did find just fat and smelly and deplorable and cruel. But I never imagined that the people who have they're wearing clean clothes, they talk a decent vocabulary, they seem to be rather sophisticated and a little bit civilized. And this is what they do? They just slander you because you disagree with an argument they're making that is ludicrous and preposterous on its face. It can't make any sense to a reasonable person, and they have absolutely no evidence to support it with. And they just say, you must believe in my God, or else I'll insult you. And they call themselves scientists. Truth seekers. What a joke. What a pathetic, horrible joke. Yeah, I mean, I way underestimated the deplorability, the disgusting nature of the human organism. Ugh, God, you people suck. Jesus. Such bags of horrible suck. Alright, so this has been DraftPhysics.com. Debate physics, but again, they won't debate physics. They'll just accuse me of crimes and slander they'll put words in they'll put words in Einstein's mouth, they'll put words in Newton's mouth, so why wouldn't they put words in my mouth? Of course. They're just such lousy liars. So they can't debate anything because all they have is lies to debate with. Disgusting. Ugh. God, I hate this planet.